If you look at the problem, you'll see the term manual static scanner. The technique mentioned here is considered an old method that is no longer in use. Likewise, you can just take this as a reference. The only real advantage of this old method is what's mentioned in option D. So, just remember that providing a wide field of view is the advantage of the manual static scanner mentioned here, and you can move on. Now, let's look at problem number 282. This is a question related to frame rate. Of course, I can emphasize that this is important. Yes, this is a question where you need to choose the option that does not significantly affect the generation of image frames. Basically, factors like the focal zone, the number of lines, and depth can be considered to have an impact. If you look at option D, it mentions the propagation speed when adding tissue, and you can consider this to be related as well. If you draw a diagram, I have explained before that the more times the signal travels from the probe and returns, the higher the frame rate will be. However, depending on whether the object being penetrated has a slower or faster propagation speed, the frame rate can change. In other words, the time it takes to go and return and the speed at which it propagates can affect the frame rate. So please remember through this question that option D is also related. In this case, you should also note that the transducer aperture is not related to the frame rate. Let me emphasize option D once again. Some people get confused about this part, but if the speed is fast and it goes and returns quickly, the frame rate can be higher. If it encounters an object where the propagation speed is slow and goes and returns slowly, the opposite effect can occur. You can summarize it this way. Next, let's move on and look at question number 283. I can tell you that if you organize the related keywords for this question, it will be easier to understand. This question asks what happens if you increase the number of scan lines per frame. In video, if the scan lines were at this level and you increase the density here, it means the number of these lines increases. In this case, the factor that is directly affected is the lateral resolution in option D, which is improved. So, you should note that this explanation is related to the choices given here, as you can see from the question. Let's move on and look at the next question. If you look at the question, a diagram is provided and you are asked to select the relevant answer. Yes, since this isn't a particularly important point, let's just quickly check the correct answer and move on. If you look at question 284, it's asking how the annular array method is represented. Among these, you should remember question 284. The annular method corresponds to option C among the choices. It's generally referred to as a concentric circle shape. So you can see from the question that this kind of shape is related to the array type among transducers. Let's move on and look at the next question. If you look at question 285, yes, it asks about the shape of the probe that represents the linear array method where elements are arranged sequentially. Among the choices, you should select option A as the correct answer. This method refers to the way each line is arranged sequentially like this. Just take note of the general shape for reference. Now let's look at question 286. In the question, the term single element disk is given. Yes, the one composed of a single element disk corresponds to option D among the choices. Similarly, just be aware that such a thing exists. Among these, the most important point is to carefully check the annular array form mentioned in question 284. Next, let's move on and look at question 287. This question contains an important concept, so I will emphasize that first before starting the explanation. The expression omega hertz is important here. It says that a linear array transducer is being used. The size is described as 40 millimeters. It's a question asking about the approximate width of the image that appears here during the value phase inspection. Basically, in the case of the linear type, it takes on a rectangular shape like this. If we assume that the size here is 40 millimeters, the related parts and the overall size will maintain the same shape. Therefore, you can consider 40 millimeters as the correct answer for the width as well. If the term convex had appeared in the question, the width here and the size on the far side could be different. But in the case of the linear type, it is a question checking whether you know the concept that the width remains the same. So make sure to check the keywords carefully. Also, if specific numbers are given, it usually means the question is trying to assess your understanding related to those figures, so keep that in mind. Now, let's move on and look at question number 288. Looking at the question, it asks what advantages the convex linear array method has compared to the sequential linear array. In the case of the sequential array here, you can think of it as a typical rectangular shape. For the convex type, you can imagine it as spreading out widely in a fan shape. The biggest advantage is, of course, that it can provide a wider near field. Additionally, a key feature of the convex type is that it offers a wider image even at longer distances. The advantage you gain compared to this is represented by option D, which includes both options A and B, so you should select D. Next, let's move on and look at question number 289. In the question, the key phrase is that the image sector angle has been reduced. If you draw a diagram, this question is asking what changes occur when the sector angle, which is about this size, is made narrower. Since the range itself is reduced, you can see that the scope of work that needs to be done also decreases accordingly. As a result, you can expect an outcome where the frame rate increases. So you could say that the thing most closely related to the sector angle is the frame rate. This part is also important, so I want to emphasize it. Next, let's move on and look at question number 290. If you look at the question, it is asking which examination requires the highest temporal resolution. The fact that temporal resolution is that important means that the organ in question has rapid movement. The correct answer is the heart, which you should select for this question.